All right, guys, we're on to day 9, converting equations from rectangular to polar. We've had practice converting rectangular coordinates to polar, but now we're actually going to do equations. And I'm going to be honest with you guys, it's going to get a lot tougher than it has been already in the unit. So I'm asking you, begging you guys to reach out for me, come to the Google Meets, and ask all the questions you need to, because it is going to start getting tough. And here's where eventually we're going. You guys have an equation 3x minus 1, and I ask you to graph that on the old xy plane. You guys would tell me, oh, I've seen this all my mathematical career. That's a line. Okay, that's going to be a line. All right, well, what would it look like on the polar grid then? Okay, what would it look like on the polar grid? So that's where we're going to today. And to be able to do it on the polar grid, you need it in polar form, the equation. All right, this wouldn't be any good on the polar graph because it's in rectangular form. All right, so our goal today, and there's only 4 questions, but they're kind of tricky. They're going to be tricky, is take an equation that I could graph on the xy and what would be its polar form now. All right, before I get started, reminder of 2 equations that we've used in the past that we're continuing to use, and I'm going to introduce a new one that you'll need too. All right, so again, here are the 3 equations that you're going to need. The first one is x equals r cosine theta. So everywhere I'm going to see an x, I'm going to substitute in r cosine theta. You also remember y equals r sine theta. Everywhere I see a y, I'm going to substitute in r sine theta. And finally, all right, I'm going to introduce a new one that we'll see as well, which is the following. Sine squared theta plus cosine squared theta equals 1. Okay, so if I see sine squared plus cosine squared, I'm going to substitute in the number 1 instead. Okay, so here we go. 4 questions. Let's take our time now. All right, so the first one, convert x equals 7 to polar. All right, x equals 7, not that we need to know that, but that would be a vertical line if I had you guys graph it. All right, now convert it to polar. Well, what do we already see? X's can't stay X's anymore. All right, I should not have any X's or Y's in my final equation. I should have R's and thetas. R's and thetas, R's and thetas. All right, so what is X? What could I substitute in? I could substitute in r cosine theta. Because remember, those are equal to here over in number 1, equals 7. All right, how do I know when I'm done and I've gone far enough? When you have r's and thetas, no more x's and y's. You should not have any more x's and y's. So believe it or not here, I'm sorry, we are not done. I got to read the directions, one job. Leave your final answer as r. So we need r equals at the end. Okay, r equals. So you see it's r times cosine. So how can I get rid of the cosine? I can divide both sides by cosine theta. So here we go. R is equal to 7 divided by cosine theta. No more x's and y's. And r is solved for it by itself. So all these we need to do here is r needs to be by itself. Okay, so substitute in, solve for r. That's our goal. All these problems here. Substitute in for, substitute, solve for r. Substitute, solve for r. Here we go. Moving right along. X plus y equals 5 to a polar. All right, so here we go. I can't have x's and y's anymore. All right, got to have r's and thetas. So what can I plug in for x? Here we go. R cosine theta plus, what can I substitute in for y? Look above. All right, look above. R sine theta equals 5. Okay, so I got rid of all the x's and y's. I substituted in. Now here's the tricky part. Can we get r by itself? And some of you guys probably are not going to see how I get r by itself because you're saying to yourself, whoa. There's 2 r's here, and I need to make it into 1. So here's what we're going to do. And this is just something you're going to get in the habit of doing by practicing this. Practicing. All right? Factor out an r. They both have r in it. So take out an r. And watch what happens. When I take out an r, those two just become 1 now. And what's left inside when I take out an r? Cosine theta plus sine theta equals 5. Okay, so I factored out an r. Okay, now this is not the same as number 3 because cosine and sine are not squared, so I cannot use number 3 up here. All right, so again, how do I get r by itself? I'm going to get rid of cosine plus sine theta by dividing it on both sides. How do you undo multiplication? You divide, right? Okay, so going up here now, I'll have r by itself, and then what do I have on the right side? 5 over cosine theta plus sine theta. That's in polar form now. Okay, only r's and thetas are left, no x's and y's. Whew. All right, hopefully we're doing all right. Again, substitute in, figure out how to get r by itself. Okay, next up, x squared plus y squared equals 9. All right, let's substitute in. Ready? In for x. X only. Ready? R and cosine theta. And we got to all square that because it was the x was being squared. So I'm going to square that part. Plus r sine theta all squared equals 9. Okay, so all I did was substitute in first, so we're good there. Now I got to deal with the squareds, and what happens? All right, how does that affect what's inside the parenthesis? How do these 2's here, exponent of 2's, affect what's inside? Everything inside gets squared. So this one's going to become, ready? R squared cosine squared. See how that worked? Plus r squared sine squared. That's how the squared affects it. All right, most of this, guys, is just algebra, figuring out the algebra. Okay, now remember we got to get r by itself, and very, very similar to number 2, what can we do? Both of them have an r squared, so I can factor out r squared. And when I factor out r squared, what am I left with? Cosine squared plus sine squared. Ooh, beautiful. Equals 9. Okay. Moving on. Oh, hey now. What do we got there? That's my new one I added, right? Right here. Sine squared plus cosine squared. I can substitute in a 1. So all this is going to become is r squared, because r squared times 1 is r squared. R squared equals 9. Still got to get r by itself, not r squared, r by itself. So you guys are right. Take the square root of both sides. R equals 3. There it is. All that work, the polar form was just r equals 3. Okay? All right, I know it gets a little confusing, but we just got to get in the habit of doing these. All right? You substitute in, look to factor, and then see if you can substitute in again, try to get r by itself. All right, here we go, kids. Let's see if you guys can take this one all by yourselves here. All right, I see x's and y's. Substitute, substitute, substitute. R cosine theta, square that bad boy, plus r sine theta, square that bad boy, equals 4. Another plug-in. R cosine theta, right? Okay, here we go, guys. Here we go. R squared cosine squared plus r squared sine squared. This over here, 4r cosine theta. That was it. If you think there should be a 4 in front of the cosine right here, nope, nope, nope. All right. It's not an exponent. All right, so I don't apply it that way. Okay, take a look. You guys know what I can do on the left-hand side. What did we do in number 3 to the left-hand side? We took out n, r squared. Stay with me, and I'm left with cosine squared theta plus sine squared theta. We're doing hardcore math here, kids. equals 4r cosine theta. Beautiful. All right, let's go. What do you see? Cosine plus sine, that's the same as, what could I substitute in? 1. So r squared equals 4r cosine theta. All right, now here's where it gets a little crazy. I know a lot of you probably want to take the square root of both sides. I get it. I get it. But here's the problem with doing that. Look on your right side, guys. Look on the right side. If you take the square root of that, are you getting rid of that r right there? No, you're not. You only want one r in the whole thing, and you're going to end up with 2 still. All right, so that's no good. All right, that won't happen taking the square root of both sides in this case, because I'm still going to be left with an r on the left and an r on the right. Okay, so what are my other options here if I cannot square root both sides? Ready? What I can do is, and I don't know if anybody's thinking this right now, if I can't take the square root, you can divide both sides by just r to get rid of it. Divide both sides by r. Then what happens? What are you left with on the left side? R squared over r. 1r cancels out each, and you're left with just r. On the right-hand side, those r's cancel, and you're left with a 4 cosine theta. Look at that. Okay, so a heads up with that. All right, heads up with that. Guys, again, don't get frustrated. That's why I have all these Google Meets every other day for you guys to pop in and ask any of your questions. All right, substitute in. Okay, substitute in. Do your algebra. Look to factor. Look to take the square root. Get r by itself. All right, r by itself. All right, best of luck to you on the assignment, which looks to be only 4 questions again. And I'll tell you what, they look pretty darn similar to what we just did up there. Okay, so you're on your way, guys. You are on your way. Just make sure r gets by itself in the equation. Good luck, guys.